So, we're moving on our schedule and the agenda with Dino Esposito. Dino, a prolific author of more than 20 books and over 1,000 of articles, has educated generation of developers through his works through Microsoft Press, conference talks, and extensive training sessions.
Now, serving as a CTO for Crionet, Dino applies his deep expertise to lead global IT operations for professional tennis and paddle, while continuing to share sharp insights on platforms like LinkedIn and his blog, Pragmatic Opinions.
The speech has the title Unpopular Opinions about Software Architecture. And Dino, welcome, and the stage is yours.
Welcome. The timer
It's okay now. Yeah, good. So the thrill of being announced is, unmatched. So the image has been AI generated, so no copyrights yet to pay. Just unpopular opinions about software architecture and development with a very short preamble. Before the pandemic, I used to be a freelance and writing books, talking at conferences, doing training, but never working on field day by day. The pandemic changed everything, so I had to find, to get a job, a real job, and now I have a full-time job, a full-time position, and I take care every day with software development. Personally, I work for a company that operates in sports, and we are responsible for ensuring operations in professional tennis and paddle. So if tennis tournaments all over the world, all over the place take place every single week, multiple tournaments a week, it's because of our platforms. So our software, and in general the software, has to work. But more in general, when it comes to thinking and speaking about software applications, we fight as developers, as architects, we hate the term legacy application and consider that as something as bad as possible. But in reality, a legacy system is a system that has withstood the test of time. It's been there for years and years, often decades. So being able to write a system that becomes ultimately a legacy system is the best success we can achieve in this industry. So how do we build a system that becomes ultimately a legacy system? The answer is pretty much obvious. Do it right and avoid technical debt. Couldn't it be easier? But doing it right poses a few challenges. In particular, what is acceptance tests? For us, for everybody, is the the necessary step to get the money, to get the contract officially honored, and the final piece of money to be paid. But acceptance tests, however, are not specs. They have nothing to do with the specs, with the problems and sub-problems that the final articraft we define, we deliver, is expected to solve. So focusing on acceptance tests when planning a system that we would like to have withstanding the test of time is the wrong approach. We don't have to focus on acceptance tests because they are simply a checklist to have the customer decide to pay. Edge cases. Now, we know that the system has to be carefully crafted, has to be fully tested, and deployed. But only in production we spot real issues. So some of these issues that emerge suddenly in production, some of those can be imagined earlier. Not all of them, but the more you know the business, the more you know the product you are delivering, the more you can imagine and foresee a number of issues. Now, who is the figure that best spots those edge cases? If it's the product owner, whatever is your definition of product owner, let's say it is the individual that is inside the project we are building. It could be the one who talks to stakeholders, to customers. It could be just the individual, the manager in the company responsible for a B2C or B2B product, or just can be a member of the team. It can be a member of the business development office in the company. Who is responsible for, who foresees, who imagines, figures out the final delivery? If it's only this individual, this team, or this figure able to spot edge cases, it means that we have a problem, because we have engineers that are not fully inside the business domain. A good sign is when engineers, developers, are also able in their everyday routinary work to spot edge cases and fix them or raise them automatically. And now the third issue of doing it right is syncing knowledge, not just knowledge about the product, about the features, about the specs, but syncing knowledge between the business side and the development side. The product owner thinks engineers know something, but not necessarily this is the case. Or sometimes, often happens that product owners think engineers need to know something, but it's not exactly the type of information that engineers need to do the job rightly and correctly. And these gaps, when they happen, are discovered only when it's too late, when you are in production. Now, end of the preamble. Unpopular opinions. I have summarized, given the relatively short amount of time for this talk, in only two main topics: architecture and testing. When it comes to software architecture, microservices. What else? Funny story. Probably 6-7 years ago, around 2017, I guess, I was invited to speak at a conference. And my talk, the title of my talk was, I had microservices and I didn't know. The origin of the talk was given by the fact that at some point I realized that what was my major customer of the time, I was a consultant, which is, by the way, my employer now, I realized that the company had a variety of sparse applications, all together forming a network of interconnected line of business apps. So I said to myself, well, this is microservice kind of architecture, because I have services that, to some extent, provide features to the whole application representing the ecosystem of the company. Then I went to the conference presenting this vision. And I got a question from the audience saying, but your definition of microservice is not the right one. And the guy went on and said, because microservice means a micro function. Is the size of a lambda. It's an endpoint. It's a small chunk of function. So a microservice architecture is an architecture in which all your business function points, to some extent, are independently deployed with their own database, treated autonomously. It took me a while to realize that we were talking about rightly talking about both, about the microservices pattern, but at different scales. So imagine you have a single line of business application, and you can make it cloud native. You can put inside of that lambda-sized microservice, deploy them to a serverless environment, to a non-serverless classic environment, whatever you want. You have a single line of business app, no matter how large it is, but it's one app serving one purpose, within the company. But it's different when we move from the single line of business application to an enterprise ecosystem, and we have tens of connected line of business apps. Now, all of them, or a few of them, can be taken individually, articulated with the classic microservices pattern, and be made of several independent components. And, however, in your vision, you are at some point. If you are a CTO, you probably see all of them interconnected. But if you are a developer, if you are an architect, if you are a team leader, you probably see only one of them. And when the message passes that microservices is perfect for everything, we are essentially moving to this. If we remove the barrier around the macro line of business apps, we end up in a single environment in which, instead of having a few modules, there were 8, 9 in the previous slide, we have a myriad of smaller services. And we experience a wonderful explosion of complexity. Because try now applying literally the best practices of microservices. Try giving each of those components and points its own database. Try logging features, behavior of each of them, and put the things together. Try with a join between the various databases that each of those things manage and is responsible for exposing. So the point is not questioning whether microservices is right or wrong. It's mostly wrong, but that's another story. That's my opinion. The point is, are you really aware of the complications that a full-size ecosystem organized in microservices bring? During the pandemic, when I made the decision to switch to a full-time software development position, the company I worked for got an engagement for rebuilding from scratch the tournament operation platform. So the software that allows supervisors to run all the daily pre, during, and post-tournament operations. So we identified something like 5 or 6 macro modules. The one responsible for scheduling matches, the one responsible for providing live scoring, tournament configuration, messaging all the way through, and draws. And we considered building a canonical microservices architecture. So something like a front end, an orchestrator to load balance and to act as a gateway, and then a variety, even just the 6 or 7 module that we identified, with some distinct databases, one for keeping the schedule, one for keeping the draws, one for keeping the matches, and so forth. We went with a non-microservice but monolithical application for these issues. Because we spot that, how do we handle latency? Because every call is an HTTP call now. There is nothing like in process. Say what you say, but in process is anyway faster. Additional cloud costs. One thing is one app service. One thing is multiple app services. You say, sure, but with multiple app services, you can control scalability in a much more granular way. True, but that was not our main problem. We didn't have the need, because this was not, and this is not 5 years later, is not an application for which you have to think of scalability issues. When at some point, we changed the plans, the Azure plans, but it was just a sort of vertical scalability. We just raised up the power of the database. We just raised up a bit the CPU time. That's it. No need to be granular. It was one of the requisites, one of the specs. And we made our decision based on that. But more, another point was logging. Okay, one thing is logging live matches or schedule, but in the business, the schedule is tightly related to the draws and to the tournament configuration. And making queries involves querying from schedule to matches to config to draws. So how do we do joins across different databases? How do we handle transactions? You say, yeah, sure, it's possible. You use yet another layer of code that allows transactionality over multiple apps. Why doing that when we have no need to get this complexity? So we went for a classic, a canonical monolith system, which is happily standing the test of time. The contract was till 26, so we have still 2 years to run, and it ran beautifully for the past 4 years. More in general, consider that even the most distributed app you can think of was in the beginning a monolith. Everyone, when it comes to microservices, talks about Netflix or Amazon. Yes, but they moved to distributed systems from a monolith in different times. I was in this business when around the early 2000s, Amazon started talking about, the tech people from Amazon started talking about the SOA architecture, service-oriented architecture, to break up the monolith that was making the fortune of Amazon of the 90s into blocks that could be scaled and improved to become the giant we know today. Netflix did it a few years later, but again, improving from something that was in the beginning a small thing, a relatively small and compact thing. But there's more. You probably know that I wrote quite a few books for Microsoft, and trust me, I wrote a book last year, but before that, the previous architecture book was written around 2014. Okay? At that time, I had, as a tech reviewer, one of the major engineers, architecture engineers in Microsoft, and the message was, the feedback we've got was, tell people to write systems that are as compact as possible and maybe scale horizontally by multiplying instances. It was all about monolithic and super compact systems multiplied. 2 years later, it was all, the same person was saying it's all about microservices. So there is a lot of hype in the industry, no matter what, period, end of the story. No matter what. So focus, the best advice I can, if you allow, I love to share is look at your own things. And keep in mind a bunch of general rules. So when you face the building of a new system, you have a bunch of specs to look for. You form an idea about which logical functionalities altogether make the app. So you come up with a long list of functional points. We can call a logical decomposition of the system in a long list of microscopic functional points. And we are still in the realm of paper. Then those things become microscopic services. So class libraries, classes, real code, running code, encapsulated in some language-specific container. We are still on the developer machine. We are not yet talking about deployment and production. So once you have a long list of implemented microscopic functionalities, you have simply two ways to deploy that. All in a single container, monolithic deployment, or you partition the services in multiple deployable units, and you have a microservice architecture. And you can move back and forward between these two scenarios. Even when you are monolithic, by the way, you still have these blocks contained inside, which are isolated because they represent a single piece of function with a clear interface to the rest of the world. So it's monolithic, but it's modular. This is key, of course. So monolithic doesn't mean writing code and to start to bottom as it happens. It means be serious in your analysis, identify functional points, treat each of them as an individual unit, which doesn't have to be necessarily deployed as an individual unit, and separate development from deployment. Even the most distributed of the popular today's applications started, trust me, as a monolith. Testing. Try posting on any social media anything against unit tests. You will be killed. Yeah, you're not a professional. You're not a professional. If you want to be a developer, you have to write unit tests first or later, but unit tests with deep coverage, blah, 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 blah. I'm not saying, I don't want to say that I disagree, but I have, I perceive polarization, yes, no, in strong positions with rejection between, like electrons, rejections between the positions when it comes to testing. Now, let's try to be as analytical as possible on the role of unit tests. First, I believe that if you are born engineer, you are not born tester. It was funny because in the Sandor keynote this morning, it showed at some point a picture with two people, two developers, and one tester, and the tester standing. Yeah, you recognize, the tester is not the developer, you recognize it. He has a different mindset. He has to be a different mindset to be a great tester. All the great testers, very few of them, that I had a chance to meet were bad developers. Because developers tend to focus on logical solution and logical behaviors when they test. So as a developer, because of your major attitude, you struggle thinking in an adversarial ways. You think of how people could do things the right way, not anything stupid they could do. When it still happens to when still I write code, I see a parameter in a method and say, should I check for nullness? But who would be the idiot that would do something to make this parameter null? And sometimes it happens. If I say, who could be so stupid to make this parameter be null, means that it's extremely unlikely that the sequence of calls that bring to that method could make that parameter null. But yet, sometimes, missing a null in a place that I would bet the house it won't be needed, it was needed, and I bet the house, and I lost the house. A tester has a different mindset, like a criminal, like a psychopath. I want to break your code. Any look at any code is like, he's a hacker trying to penetrate the code. And more than everything else, unit tests are a guarantee of nothing. Sorry about that, but they guarantee nothing. Not because your unit tests passed. You can state, you can sign a contract with your blood saying the app will work in production no matter what because I passed all my tests. No matter how comprehensive and coverage, correctly written, verified, maintained, kept in sync with the code your tests can be, they prove just nothing. They are not and they cannot be the guarantee that your code will work in production. I cannot remember neither who was the person that when I printed in my mind a sentence I heard at some point. Unit tests are for the developer, individual developer self-confidence in what he is doing and delivering and committing to the repository. It's guarantee of nothing. Do you need to have tests or not? It's up to your individual experience, or if you have to comply with company rules, okay, company rules, but even if you comply, if you do tests because you comply, they anyway prove just nothing. Unit tests only find the bugs that unit tester author has thought of. And again, the developer has a different mindset than a tester. So company I work for, we don't do unit tests, if not, occasionally. And the question is, okay, you don't do unit tests, but how do you lack? How do you survive the lack of unit tests? Because unit tests guarantee, anyway, that possible bugs are caught in advance. Now, these rules work for our scenario, so I'm not saying that this works for everybody, but I just share this piece of knowledge. The entire team know the business domain very well. So we write software to ensure the continuity of tennis tournaments. We know the rules and the processes of managing tennis tournaments nearly in the same way as real professionals doing that for a job. This has an immediate consequence. We write code, and we know why we write the code. Too often, it happened to me in my career to talk to developers, question some of the solutions they implemented, and asking, but what is the point of this method here? And they didn't know, because that was written in my user story of the day, of the week. With no idea of why that piece of code was ultimately necessary. And anyway, with a limited amount of tests, we surely accept the risk of facing regression. We fix something, we add a new feature, and we break something else. Yeah, sure. It's part of the budget. How do we cope with that? Essentially, behaving like actors on stage that are preparing the show. We study, today, actors study the script and rehearse on stage. We write our code and play it on test machines the best as you can. Go through a series of try session, repeating critical operations until we feel confident it would work in the real world. And if it doesn't, we fix, we react. That's part of the deal. We react and fix bugs quickly. So, again, to mention one of the statements heard this morning in the Sandor's presentation, he mentioned the 90-90 rule. Okay, 90% of the time is for 90% of the features. Go to production and fix the remaining 10% as soon as you can. And not working for every possible scenario, but you have no you have no alternative. You have no alternative. Not because you have tests, you can put your life at stake that it will never fail. I can bring the experience. We built the system in 3 months, a system that was planned to take 9 months because of the pandemic, because then it stopped for 6 months in 2020. We tried to go live the 1st of January, starting the 1st of October, building from scratch the system. We made the first couple of tournaments in January 2021. It was a nightmare with people managing changing data in the database live, but we made it. And in March, the system was production ready. And from March 21 up to now, and for the foreseeable future, it will only experience major improvements, minor improvements, but evolutive maintenance, but nothing that could be qualified as the system doesn't work. Okay, so no one cares if your features work in a staging environment, in a protected environment. But everyone cares if the system works in production. We usually have staging environments, sure, we have, but nobody uses them. We will release, update the software in staging environment for a number of people to test, and nobody tests that, not carefully. Not with the same interest, with the same passion, with the same participation as they do on live systems. Put another way, more philosophically, once you deploy, your artifact ceases to be code and becomes a system. So it could be said that you enter by deploying in a phase in which you test system. So you must be, that's my advice, ready to imagine solutions that make it easy to test the system live in production. I test in production. If you Google for test in production, it's something that it starts being talked lately. It's a matter of months. I mean, the first time I ran into that was this summer. But it's a point that is gaining a lot of interest. I'm also contributing to that with articles and things. And the first assumption is test and staging environments are an illusion. Period. End of the story. Because you will never be able to replicate the complexity and the participation, the surprises of the real world. The real stress test comes only in production, period. Face it. Same time, pre-launch perfection, it's mirage. You will never reach that. Every deployment is, in fact, an experiment. Again, another quote, another word that echoed this morning. Everything is an experiment in the Sandor presentation. Thinking you can avoid every problem by thoroughly testing before release is wishful. Not that you don't have to do it, but don't build expectations on that. So the ability to test, to react quickly and promptly in production, that becomes critical. And if you Google for test in production, you will find something called feature flag, feature toggling. That is, without knowing the name, exactly what we did for the past 3 years in this tennis tournament platform. We release new features without breaking anything, only for 3 people to look at that. In production, because it's problematic, given the scenario, to have test data that is the same. So enabling testing of some features and toggling on and off in case of troubles is exactly what we did. So feature toggling, and there is, by the way, also a small library within the .NET framework to help with that. It's stupidly done, but it's there, the idea is there, to help you with toggle on and off things, which is basically put in critical functions or just menu items behind an if statement and read the settings from a database, period. End of the story. That's it. But logically, it's feature toggling, and that helps you to build a strategy for having resilient, reliable services and to give you the necessary flexibility to handle production issues. Any bug, final quote, is not fixed until it's fixed in production, and nobody cares about everything else. Thank you very much for your time.
Great, Dino.
Also,
Thank you so much.
also perfectly on time, I guess.
Perfectly on time, yes. And we still have enough time for questions.
Yep.
So give us a few minutes to open the screen.
Excellent.
Right.
No, okay. Okay.
In order to be able to view, okay.
All right,
Yes,
yeah.
perfect.
To check for the questions.
AI will change the role of devs. Oh, No, the role, I don't think it will change. Personally, I use, and all the people I work with use ChatGPT and to learn, in replacing Stack Overflow, essentially. So in this case, it won't change the process, but it will change the effectiveness of the process of getting quick solutions, ideas, startups on certain features. I don't expect at all, at least for the time being, AI to be replacing anything, but it will be a much more powerful tool for developers to do their own regular job, but also for teams to build products with advanced features. It's okay. Let me share an anecdote. Last week, meeting within the company, we were discussing a POC we did for a customer, and it was a software that monitors from fixed feeds, URL feeds, having laws and amendments to laws in the parliament, monitors what could be interesting to certain customers. And the funny thing, when we reviewed the code, and the funny thing was that it was code. It was an algorithm in which at some places here and there, we call an LLM to get this, an LLM to get that, another LLM to get this. But they were just function calls, essentially. But the building, the application was not writing the prompt for one LLM, but combining together the capabilities and the behavior, the specific abilities of certain LLMs of doing certain jobs. But the logic for producing the actual output was human logic, was algorithmic, conceptual logic. So AI are just fantastic tools to take the things we can build to the next level, but in my opinion, they will not affect, if not for better, the role of the dev.
Mm-hmm.
Second one is, if you could give only one advice to a young programmer, what would that be?
Nearly the same question was asked this morning to Sandor, and I mentioned Sandor many times today, because I find myself in his same shoes for many of the things that he said this morning. And when he replied to a similar question, saying that in his company he loves to hire primarily, especially young developers, which is exactly my situation, for exactly the same reasons that he mentioned. So I would just take his words, saying because they are eager to learn, and as an advice, be eager to learn is the only best thing, the only great thing you could do, which is, by the way, the thing I did in the beginning of my career at a time, early 90s, in which, can you believe that? There was no JPEG around, and we were doing digital imaging without JPEG. So in 93 or something like that. So yes, eager to learn.
Great.
Okay. Okay, so these are all
That's
the
all?
questions we
Okay,
have.
Great.
Thank
Thanks
you
a
very
lot, Dino.
much.
Thanks a lot.
Thank you guys for having me here. Bye.